The next part, find the least squares regression line. That certainly is something that requires some work, right? So we'll go ahead and do that. Now, what does it mean to find the least squares regression line in linear algebra? Well, here's the formula that you get from the textbook. And we define A, the matrix A, as this guy, which is going to be fun unless we use a calculator, in which case it's going to be really easy if we use a calculator, more or less. And remember that the sum of the squared error in this class is E transpose times E. Okay, so we're going to use those to figure out what the least squares regression line is. And the first thing you have to do is pick the points that we have off the, I had it up here. Pick the points that the actual data points that we have, right? And so I'm going to list those. What data points do we have? We have 0, 4. We have 1, 3, 1, 1, and 2, 0. Now, I have to figure out what my x is. Well, x is always, that's a matrix that always, for the first column, is always just 1. And there are going to be 4 rows because I have 4 data points. The second column of x is always the list of x values from the data points you have. So that's my x. Now, y, the matrix y, is always just the y values corresponding to the x values you just wrote down. So in the data points, 4, 3, 1, and 0. And now I really have to figure out what a is. As we know, a is going to be x transpose times x, and then I'm going to inverse that, multiply it by x transpose, then multiply it by y. Okay? Okay, so the idea here is I'm going to try to maximize the use of my calculator. Now you may say, well, since we can't use the calculator on the first test, how are you going to ask me a problem like this? Well, that should answer your question about whether or not this is on the first test. I'm not trying to spoon feed, but you should be able to figure that out. Okay, so I just, if you watched my last video, I had this question, or sorry, I had this matrix in here, the 5 by 5. Now I'm going to change that, and I'm going to keep track of what A, B, C, etc., what I store X, Y, and E in my matrix, in my calculator as. Really, I'm just going to use X and Y, and I'll show you how to deal with E in a second. So my matrix A is going to be X, okay? And so that's going to be a 4 by 2 matrix, and hopefully you can see that. Yeah, you can. Let's see. First entry is 1, and then a 0. Second row, we have 1, 1, 1, 1 for the third row, and 1, 2 for the fourth row. So second quit. Now if I go ahead and edit my B matrix, so let's see. I guess a little confusing that I called A X when there's an A in the problem, but you can get over that, right? Maybe we'll call this A prime, right? So my B matrix is going to be Y. That's a 4 by 1. We already have it written down right in front of us. So this is 4, 3, 1, 0. Second quit. Now I always like to check my matrices. A on a clean screen. Sure enough, that's my matrix X, right? And then, oops, second matrix B. That's my matrix Y. Sure enough, I have everything. So here's the fun part. I'm going to show you a shortcut to figure out how to, okay, so we said this was A, right, in the calculator. and this is B in the calculator. I'm going to teach you a shortcut how to do this so when we do have problems on a test that you need a calculator for, you'll be able to do them quickly. So I gotta do this. I'm going to work on the inside of that set of parentheses. So I'm going to go ahead and create the transpose of x. Okay, how do I do that? Remember, x was a in the calculator. So I'm going to go to a and then go to, again, delete, 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 delete. There we go, clear. Let's try that again. So matrix A, and now second matrix gets me to the math menu for matrices. And if you go way down here, as I remember, way up here, 2 is the transpose, right? Now, what does A transpose look like? Oh, it looks like that. I could have just done it by hand. It's easy enough, but I want to show you this. Now, that matrix right there, A transpose, is in the memory of the calculator, isn't it? So if I just store that matrix into one of my matrix slots that hasn't been used, I'm going to use C. So second matrix, go down to C. I'm going to store that as C. So A transpose is now in my calculator C. Just putting that there so we don't forget, right? X transpose is now C. All right, now I'm ready to do the fancy work. I have to multiply X transpose by X, so that's going to be C times A according to our notation. So C times A. And then I'm going to get, so that is what's in my memory, right? Okay. And if I just take the inverse of that, answer inverse, right? Then I end up getting what I can work with. Now I'm going to multiply that by X transpose, which remember in our calculator is really C. And I get this ugly mess. Now I'm not even going to deal with that because I've done everything up to here so far, right? All of these. I just have to multiply what I got, the answer, by Y, which remember was B. And sure enough, I get an answer back. So this is what A prime is, isn't it? A prime is 4, -2. Oh, well, that's what I wanted, because that means that my least squares regression line is Y equals 4 minus 2x. Oh, that was easy. All right, good. Now, what I'm going to do next is,